I'll begin with a word of prayer. Heavenly Father, we thank you for this class. I thank you for these students. Just ask you to bless our work today as we go over the solution to this quiz, that we just resolve any remaining questions. And I just pray that the students would have an excellent break and just get relaxed and refreshed and just ready for the rest of the semester that awaits them after they get back. Lord, in your name I pray, Lord Jesus. Amen. Okay, so yeah, we won't have class Friday, not in person anyway. I'll send you guys a video that you can watch when you wish, and then so Monday after break, start a class. I collect mission 3, right? We go over the solution to it, and then you got test 3 on Wednesday after break. All right, so that's the plan. All right, so here's problem 1. Problem 1. So first of all, this one, not invertible, fails the horizontal line test. So game over there. This one passes horizontal line test, so we can flip the graph with, basically I took this minus 6, 8, and flipped it to 8 minus 6. Took this 6, 4, flipped it to 4, 6, and connect the dots. That gives you the graph of the inverse. So fun fact, you might want to remember, if you have a function that's a line, the inverse is also a line. So now problem 2. Problem 2 is a little bit more exciting. Problem 2, I don't know if we've worked exactly problem 2 before, but you should have everything you need to solve problem 2 if we just combine the concepts that we've gone over. So to find the inverse, the formula for the inverse, we write y is equal to the expression which is given, in this case 2 plus log x minus 3 minus log x minus 7. Then my goal is to solve for x. So to achieve that goal, I use properties of logarithms to collect the logs into the log of the quotient. I subtract the 2 to the other side. Then that gets me to y minus 2 is equal to the natural log of this quotient here. Then to get rid of the natural log, I exponentiate the equation. Exponentiating the equation gives me exponential of y minus 2 is equal to the exponential of the natural log of x minus 3 over x minus 7. But since exponential and natural log are inverse functions, these be canceling, and just leaves you x minus 3 over x minus 7. Now that is equal to e to the y minus 2. Now I decided to use this notation for the algebra since I was like, I guess I'll go back to the e to the y minus 2 notation. This and that are equal. It's just a different way to write the same thing. Anyway, continuing in my goal to solve for x, I multiply both sides by x minus 7. All right? And then once I do that, I want to kind of multiply this out and keep all my x's on the left side. So I've got the x right there. It stays right there. Then this x times e to the y minus 2 subtract to the other side. I get minus x e to the y minus 2. I take this 3 and add it to the other side. And this minus 7 e to the y minus 2, it stays right there. All right. So once I get to that, I factor x out. That gives me this equation right here. And then finally, to solve for x, divide by the cofactor 1 minus e to the y minus 2, which gives me this formula. And of course, that is the formula for the inverse function as a function of y. So f inverse of y is 3 minus e to the y minus 2 divided by 1 minus e to the y minus 2. There it is. Now, I haven't yet answered the other question, which was what? Determine the range of f, right, in interval notation. So there wasn't quite enough room for me to do that there because I keep writing big. So I had to steal some white space from the next problem. Hope you guys can forgive me. Anyway, because the problem 3 is actually like super easy, because natural log of e to the x is like x, and natural log of e is 1, so that's just minus 6, and like natural log of e to the 8, well, it's 8. So problem 3, you get x equal to 14. I hope you guys got that. Do you guys get that? Anybody? I hope. Yeah. On the other hand, to figure out the domain of f inverse, well, that's a little bit trickier. I need the denominator to be not 0, right? So to figure out the trouble points, I set 1 equal to e to the y minus 2. If I take the natural log of this equation, I get y minus 2 is log of 1, which is 0, which gives me y equals to 2. So 2 must be excluded from the domain of the inverse function. But the domain of the inverse function is the range of the function, so the range is everything except for 2. There it is. What's the domain of the function, by the way? Do you guys know? It's hard to know with what I have on the board right now, but if you go back to the original function and you look at it, this wasn't asked, but if you want to think about it, the domain of the function would be 7 to infinity. I need x to be larger than 7 for the inputs to the natural logs to both be positive. So 7 to infinity would have been the domain of the function, which is to say that the range of the inverse function is actually 7 to infinity, truth be told. Now, anyway, any questions? I'll go on otherwise. Nobody? Okay. Problem 4. Expand and rewrite the expression in terms of a, b, c equal to the log of x, y, z respective. So first order of business, I get rid of this square root by pulling a half out, right? That's just easier. And then once I've done that, I use the property of logs to write this as log of x to the 5th plus the log of y minus the log of z cubed. But then I know the power property, so the 5 pulls down and the 3 pulls down, multiply through the half, and that gives me 5/2 log x plus 1/2 log y minus 3/2 log z. In other words, 5/2 a plus 1/2 b minus 3/2 c. Does that make sense? Yes, no, maybe so. Pretty standard, expand the log property problem. Yeah.
Is the letter just defined by the order?
Hmm?
The letter that you assign to each one is just defined by the order in which?
It's defined by this right here. So if I had said like if I'd switched a and b to make a log y and b log x, then I had to switch the a and the b down here too. So it's not like written in stone, a has to be log x, b has to be log y, c has to be log z. It's just that's what I did. Problem 5. I would take the natural log of this equation, probably. If I do that, then pull the x out. I get x log 2 equals to log 5. Solve for x. X is log of 5 over log of 2. But of course, on the other hand, we can use the change of base formula and see that that's equal to the log base 2 of 5. Or of course, if you want to, you go back to the original equation, take log base 2 of this equation, it gets you straight to here, right? Whatever floats your boat. The solution is 2.32 to 2 decimal places, right? So, of course, these are exact. That's approximate. But I hope everybody can solve this equation. This equation is pretty straight down the middle. Everybody should be able to solve problem 5. Everybody really should be able to solve problem 6 as well. I think we've done a problem like this at least a half dozen times in class at this point, maybe more. So here's how it goes. The log of the sum of the logs rather, is the log of the product of the arguments. So I do x times x minus 6 equals to 2. Now it's log base 4. So the natural enemy of log base 4 is to exponentiate both sides base 4. So when I do that, I just get x times x minus 6 on the left-hand side, and I get 4 to the 2, which is 4 squared, also known as 16, on the right-hand side. But that's a quadratic equation in x, namely x squared minus 6x minus 16, which factors, super dice, x minus 8 times x plus 2 equals to 0. And we have not completed this square enough lately. These book problems are kind of, anyway. So x equals to 8, x equals to minus 2 are the solutions, potential solutions, but as soon as you write down x equals to minus 2, you look back up at the equation you started with and go, ooh, you can't have that. Log base 4. Oh, come on. I meant to put log base 4 there. I'm a dummy. Log base 4. Log base 4. Of course, log base 4 of minus 2 doesn't exist in the same way natural log of minus 2 doesn't exist, but this is not really the point. The point is log base 4 of minus 2 doesn't exist. So when I plug this minus 2 back into that, it's no good, right? In fact, they're both bad. Like minus 2 minus 6 is minus 8. So anyway, but once one of the pieces fails, it's over, all right? So, yeah. And then that leaves us with 8. 8's fine. Log base 4 of 8, that's good. Log base 4 of 8 minus 6, that's log base 4 of 2. That's fine. We can do both of those. So this is a genuine solution. The other is extraneous. So we get rid of it. Problem 7 is one of these newfangled quadratic substitution problems. We've seen something like this before. I will acknowledge it's a little bit trickier, but you can do it. So whenever you see like a sum or a difference of exponentials, probably it's one of these problems in this class, I would guess. Anyway, if I let y equals e to the x, then y squared is e to the x quantity squared, which by the laws of exponents is e to the 2x. So with this substitution, this becomes y squared minus 3y equals to 4, which if I move everything to one side gives me y squared minus 3y minus 4 equal to 0. And that factors. Oh man, no completing the square again. It's such a bummer. Anyways, it factors. So that's either y equals to 4 or y equals to minus 1. But remember what y is. Y is e to the x, right? So that means I got to undo that substitution. I got to get e to the x, which gives me 4, and I got to get e to the x, which gives me minus 1. But you can look for x that gives you e to the x minus 1 as long as you like. You'll never find it, because any real x, when you feed it to the exponential, it gives you a positive output. So we can't solve that equation. On the other hand, this over here, take the natural log of both sides. You got x equals log 4, and that's it. So I'm a little bit disappointed with this quiz. In retrospect, I wrote it earlier today, and it's got a lot of goodness in it. But something it's missing that should be in here, would have been healthy for you guys to suffer through, would have been like a Newton's law of cooling problem. That really should have been in here. Sorry, I forgot to put that in here. And the other thing would be like one of those, a of t is equal to like 7 plus 3 e to the minus 0.02 t. Solve for the time when a of t is equal to 5, that kind of thing. That would also have been a good problem to put on this quiz, which I neglected to. Now those kind of problems are in the mission, so you'll get practice there. So with that, any questions about mission 3? No? All right, well then we're done. Have a good break, guys.